I ain't gonna get that one right now. We'll just do one at a time.
What is your analysis?
Oh, well, I don't know. We ain't got into it enough yet.
Oh, I mean, you can see the teeth now.
Well, I mean, that's not as critical as
the actual surface.
Yeah, you can see right here, though, it does have quite a bit of wear because half that tooth is gone.
I do see that.
All right, you see on this side, this valley, it's pretty uniform straight across here.
Yeah.
All right, when you look on this side, you see that shoulder.
Mm-hmm.
That's wear. This shows it real bad.
Yeah, I can see the deposit of material on top of the tooth.
Yeah, this would have been the original line of it.
Mm-hmm.
You can look at the head right here. See this part? See how wide the face of the tooth is?
Yeah.
How narrow it is up there? That's wore out. So these have a little wear, but these and these are much worse. You see that play right there?
Yeah.
That's not supposed to be there either.
So we got it out. Here's the seal with a spring around it. And then the main hub with a bunch of shims on it.
Here you go. Zip the tires.
Full gear's out.
Yeah.
Now we just got to get the shaft out.
Here it is.
If you get down, I'll hand it back to you.
All right.
All right, Dennis, so we got the bull gear out and the shaft that it was on. What are we getting ready to do now?
We still have some bolts and everything to clean up. And in cleaning up those bolts, they're pretty rusted. You know, we have to remember this is from 1956. So it's probably built in 55. So it's 70 years old. And everybody was blaming me for pulling these and breaking off these bolts, but it's okay. I'll live. But ultimately, we're gonna heat these back up with our induction heater and see if they'll break some rust around it, and then try to keep pulling them out, welding them up.
All right.
Good.
So one thing that we failed to mention in the beginning is that both the engine block and the chassis was pressure washed earlier in the week. That was to get anything natural or just any dirt in general that could have built up on it over the past 10 years and the previous lifespan of it sitting outside off. So they had been washed, and that's why they are now wire brushing it to clean it, possibly put the red paint on the inside and start rebuilding it. All right, what have you been working on, Dad?
Well, I got the steering clutch assembly broke down. We're sandblasting some parts. And this is the bearing. The throwout, well, I guess you call it a throwout bearing. The yoke is connected to this. You hear that?
A little bit of roughness.
Now, it'll never turn that fast, but that means it's got problems. Most likely moisture got in here and rusted the balls, you know.
Because it should be good like for 1,000,000 cycles, shouldn't it?
Yeah. So this turns all the time. Unless it's you engage your clutch or disengage your clutch, then it doesn't turn. So what do you think? Need a new one?
Need a new one.
All right, let's run to the store and get one. So follow me. So this is a 7215, I believe. 7215. So let's see what we got here. I think here's a 215. Let's see if this is the same. This one looks like it's got more balls in it.
Does that matter?
No, that don't work.
Because all we care about is that
215.
Yep.
It's the right width, right diameter. So anyway, there's our new bearing.
Well, that was quick.
This always pays to have a good inventory. So. I don't have another one though, so if the other one's bad, I'll have to order one.
Yep.
But I think this one here's different.
So, how do the clutch discs work? How do they look?
Oh, they look replaceable. So the clutch disc, Papa got them took apart. Well, not completely apart, but they're kind of stuck together right now.
It's just not
So we're going
good.
to soak them.
No, I'm going to replace them, and I'll show you why here in just a second. The inside one's got teeth on the inside. So the metal, that's the metal disc. This is the clutch material, and it's double-sided. The problem with these, we hinted on them earlier, are the teeth. Some of them are wore half in two, and some of them are not. You can see that. See how bad that's wore? And then you got, this is gouges where material was stuck to the metal disc.
Mm-hmm.
Like I imagine when I get these took apart, we'll lose clutch material stuck to the steel disc in the middle.
Yeah.
And that happens when it sets for a long time. I mean, there's really nothing you can do about it.
Which is basically resting away.
Yeah. So let's see. Here we got one that's 5, 6, 7, 8, 9, 10. Well, that's 12. And there'll be that many. I thought I saw one.
This one's separated right here.
All right, here's just a metal disc.
Okay.
And then here's the actual clutch disc. So it's got material on both sides of it.
Oh, yeah, I see a little lip.
Because it gets sandwiched between two metal ones.
Yeah.
These
You
engage,
can see the lip right there.
Yeah, these engage with the external drum, and these engage with the internal drum.
Yeah.
So when you pull the steering clutch, what that does is allow these to separate and spin inside each other.
Mm-hmm.
And so when you let off the steering clutch, you have springs that pull the pack together. And that resistance with them squeezing in between these materials is what allows you to put power down to the pinion.
Yeah.
So like this one's got this stuck to one of these discs when it came apart. So
that's what the light gray material is.
Yeah.
Patterns are. Okay.
So that's no good. That's trash.
Mm-hmm.
There's nothing you can do to fix that.
Well, you know, after 75 years, I think I'd be worn out too.
Yeah. So you know, like I say, you can see the wear. The material's rolling over there.
Mm-hmm. Rolling over?
Yeah. The edge of the tooth.
Oh, yeah.
Where's my pointer go?
There it is.
You can see that roll of material there?
Yeah, you can see it better right over here.
Okay, well, I'm not looking through the camera, but that's where it engages back and forth, you know, as it steers. Mm-hmm. And then these engage on the internal drum. So like you can see right here, this is material stuck to this disc. So we can either take the time to grind each one of these back or replace. So I'm probably going to replace just because I have to replace the clutch material. So if I'm going to spend the money to buy these, I might as well spend a little bit more money and replace.
So are they expensive parts?
Yes.
They can be because you got so many of them.
Okay.
They're available. General Gear, Boise, Idaho. Those guys are wonderful to deal with. He makes steering clutches for almost any kind of equipment. SteeringClutch.com. He's not sponsoring this video, but he's a great resource, you know, not having to go to CAT. But he offers, I think, 2 types of material for the clutches. No, it's some bimetallic type stuff. It's supposed to last longer, and it's less prone.
Kevlar? Not yet, huh?
It's less prone to stick.
Okay.
See, that's whatever this is made out of. It has a tendency to stick to the plate.
Yeah.
So a lot of times, the problem when you buy an old tractor that's been sitting and it won't steer, 9 times out of 10 it's a stuck pack, clutch pack. And so we had a D4 years and years ago on a family farm. You leave it sitting, it would have a tendency to stick. So first thing you did, you put it in low gear and you found a big tree and you've held both steering clutches back and you went up and rammed that tree. All right, well, that sudden jar would 9 times out of 10 break that pack loose, so it would steer. So once you were working the machine.
So how long did, you said it was a D4?
Yeah.
How long would it sit before it stuck? Like a day?
No.
Okay.
This is like 6 months to a year.
Oh, okay, yeah.
It's not something we used every day.
Yeah.
My grandpa used every day.
Okay.
But I mean, back in the day when you used it regularly, you didn't have that problem. This moisture would get into the cavity of the steering clutch.
So it's back to what he was saying. It's some type of reaction of the rust or something else.
Yeah, when moisture got in here, it would basically bond the movable disc to the clutch disc. So, you know, the whole purpose of this is designed to slip back and forth like that when you pull the clutch. And you got a whole box of springs there
That hold it.
that hold it all together. You got an internal and external spring. So here's your external spring.
Those are the ones we saw when we took it out.
Yeah, there's the internal spring, and they all go on studs. And it,
Packs it together.
yeah, well, there's one assembled laying there on. We're looking
So-
at the bottom side.
Yeah, so this one that you took apart, is that the one that was had the rust packing?
No,
So
that
this
was
is
the
a good
better one.
This, oh, okay. So there's not really any hope for the other one.
I'm gonna say probably not, but I mean we could be surprised.
Yep.
But
It's all about taking it apart, right?
if I'm going to replace one side, I might as well bite the bullet and replace the other side. So. I mean, those may be in this one. Well, there may be a few salvageable if we get, you know, another D6 in that needs a little work, but we don't want a total rebuild. Then we've got some parts.
Okay. So have you looked at the drums yet?
The drums, Jonathan, the external drum is right here. We've yet to clean it up. So, you know, it doesn't appear to be real bad. This is an area that we'll have to really look at. See all that rust built up?
Yeah.
That was probably at the bottom when this was parked. That was sitting at the bottom. So this got the moisture first.
But the overall appearance, are you happy with? I see some teething there where the teeth are rubbing against it.
Yeah, I think, you know, for what this tractor is going to be used for, I don't think that's a problem.
Okay.
I mean, majority of the time the pack runs right here. You know, this part is past where the pack's going to be.
Yeah.
So you're going to soak it? What are we going to do with that one?
We'll sandblast it and wire brush it.
Okay.
You come over here and Jonathan's working on the other one. Jonathan has volunteered to clean this. This is the internal drum. So the steel disc engaged with this one. The clutch disc engaged with the one we just looked at. So you can see the witness marks here where those individual discs were sitting.
Yeah.
And it moves back and forth. So, you know, this is not perfect by any means, but it's certainly usable because, yeah, this is the steel disc that goes in between the fiber discs. So those have to line up just right, and they lock in here. So they're gonna move back and forth. That's just the nature of the beast. So, you know, that's certainly usable. The other things you have to watch out on these is your internal splines.
They look warm.
If they got Well, it's not. They won't be sharp
Okay.
because the one that mates with it is not like that. But if this runs loose, these will round down, and that whole drum will be loose. But like this material here, we'll have to get that off. That's clutch material. It's stuck to the drum right here.
Okay. Jonathan's doing a good job of making the clutch material look shiny.
Doing our best.
Yeah, so we may have to take something like a chisel and work that stuff off. Well, this one won't do it, but the external drum, if it builds up a lot of heat, it'll have stress cracks in it, and it may be cracked to the point where you can't use it. That's
So this one's not cracked.
That's the piece we haven't cleaned
Oh,
up
okay, yeah. You hadn't got to it yet.
yet. Haven't got to it yet, but anyway, the springs all go through here.
Okay.
A lot
crack.
of mass.
All right.
Yeah.
So
Very
all those bolts go through here, and the springs come through on the bottom side. So this
Okay.
is what sandwiches your clutch material together.
Okay.
But anyway, it's been into several times because when I took this nut off, they had obviously chewed on it some.
Structures become much weaker in a corner. So when you have a corner, the amount of stress is
It's a stress point.
it's a stress point. The stress increases in the corner of a structure, and so you may wonder, okay, why, right? This you may have, if you work with steel a lot, you may have heard this. Try to avoid right angles, round the corner if you can, right? You may have seen pictures in the past of airplanes that have broken apart and the crack started in the corner of a window, right? Okay, so we know steel or structures are weaker in the corner, but why? Well, we happen to find a perfect example of this right here. You have a corner and a crack right there. All right, so let's say you do have to have a corner, or in this case, a rounded corner in your steel frame. And you want to know how much stress can this steel, and right there in that area, take before it cracks. So there's an equation for that, represented by this diagram. So before we look at the equation, let's take a look at a diagram. This diagram is an idealized corner.
What do you mean by idealized?
It's
It's like a perfect version?
it's simplified.
Okay.
This is a simplified diagram of this corner. So you have in class we drew it as an oval, so I kept it as an oval. Here you have the crack radius, or in this case, right, this radius.
So the oval is the crack.
No,
the oval represents the radius of the corner.
Yes, the oval represents the radius of the corner. All right. So you have your corner, right? You have 2A as the length of, right? And so this is at an edge, so it would just be A.
So what is 2A? Like over here, what is 2A?
Well, so if the crack was right here in the center of this steel, 2A would be the distance from one side of the crack to the other.
Just the length of the crack.
Right, but because it's an edge crack, it's just A.
Okay.
So A represents our crack length in this corner. This sigma, lowercase sigma, represents the stress pulling on the steel.
Sigma is a symbol, right?
Yes, sigma is a Greek letter, just like X and Y is English alphabet or Latin. Sigma is Greek. And then rho sub t, this is also a Greek variable. Rho sub t, that is our crack radius. So here, our crack radius. So if you were to draw this, continue this circle all the way around, our radius would be, let's say, 1/2 inch to an inch, right? We'll say 3/4 inch. Okay, so this is the idealized schematic of this crack in the corner we're looking at. So here's the equation. So the max amount of stress our steel can take before fracturing, right, is represented by this equation where rho sub t, as rho sub t gets larger, aka as the radius of our corner gets larger, the max amount of stress the steel can take before fracturing also increases.
So the more rounded a corner is, the stronger it is from cracking.
That's right. The less likely it is to fracture. That's why on some steel bridges, if you see a crack and you're like, that's not good, and you see somebody came with a drill and drilled out at the end of that crack, and you're like,
they're creating radius.
They're increasing the radius, increasing the amount of stress that part can take before it cracks. And so, it's like kind of counterintuitive. Why would you drill out the beam? Well, that's why. That's the math.
So you mentioned airplanes earlier. That's why a lot of airplane windows are almost a perfect oval.
That's right. Yeah,
They're
because
completely rounded.
Yeah, because the airframe flexes as it goes through the air, right? Just as your car frame flexes as it goes down the road. So stress will.
Same concept.
Yeah, stress
Okay,
will.
yeah.
Be increasing that corner, so they're trying to dissipate it. So here's just a graphical representation. Pretend this is an infinite plane of steel, relative to this
Just
crack.
a flat sheet of steel.
Yeah.
Right?
So, so stress will increase the closer to the corner of a crack. If you measure from over here, the amount of stress the steel can take is much greater compared to right there at the corner. So anyway, we learned that in class the other weekend. It's a pretty cool real world example of some material science. So hopefully you are now also smarter. Let's go back to work.
So how much did y'all wire brush earlier?
So earlier we wire brushed all the most everything. We didn't get this surface right here because Cole said it needed to remain
Where the head is,
yeah,
right?
where the head gasket goes, just because apparently we could have created divots and we don't want that. But we wire brushed inside of all the bolt holes, and here's Cole, he can tell you more, just around these surfaces, and then also we needle scaled inside the head some. It's pretty warm in there from where you steam cleaned it. But any problems?
Nope.
Cool.
Clean, yeah.
Sweet.
It's just a matter of getting it blown off and dried out. And
Yeah, I'll pull an air hose out for us.
okay.
Air hose out here. I don't actually know where that thing is.
Well, it looks a whole lot better than it was. It did.
Thank you.
Oh, so all right. So Cole, while we have you here, let me ask you a question. We didn't get 100% of the rust knocked off, like at least inside the head. Why didn't we have to? Like, why don't we have to make it perfect, especially if we're going to put?
If you're going to put glyptol in it, which is that red coating, it's an oil-resistant coating. The cleaner the surfaces that it is applied to, the better adhesion you will get.
So I know it wasn't perfect when we cleaned it. Did the steam cleaner get more of the rust off?
Everything that we knocked loose, or that it could break loose, it has got out of there now.
Okay, so
It's still not 100%, but it's a lot better than it was.
and so the amount of effort it would take to get it to 100% is just not worth it, or
Well, you can't get it by hand to 100% because there's so many pits in it. You would have to put it in a hot tank or an acid tank or something, or put it in a blast cabinet.
which is not in the budget this year. But if you subscribe, it might be in the future. So we're just gonna call it quits then, and just in terms of cleaning. All right,
Yep.
well, cool.
So what's the next step? Is it to start pressing the liners, or are there more stuff?
Well, we need to take the liners and see, since we got new liners for it, and see how many shims we need to add underneath them to make it flat. And after that, we can start putting it back together.
How do you measure that? Caliper?
Yes.
Okay.
Cool. Well, let's go get it blown off.
There's important notice here. This is not how to do it. This is how we do it channel. Okay? So we're not professionals. We're not experts. We're just country boys that can solve problems. So anyway, we're going to press the center shaft out of this. So stay back. Set the 10.
Ding dong.
Did it come out or something break?
No, it loosened.
Huh?
It loosened.
Oh.
Here's what we just pressed out.
So is it supposed to be pressed in like that?
Yeah.
Oh, okay. It's not just stuck.
No, it ain't stuck.
Okay.
All right. So now we're going to press our springs out.
So the springs have a keeper.
Yep.
So that's that little pin you're spraying around?
No, well, that's the pin. The keeper goes around the pin.
Oh.
It's not necessarily for this particular model, but it works.
All right. As long as we get it lined up right. There we go.
So
So those springs are a little bit larger than the diameters we have.
Looks like you're pushing on some of the center pins. You're pushing on this pin. Some of them are coming out and some of them aren't.
well, that's because the pin's not supported underneath there.
Oh, okay.
So there's the keepers, huh?
Yep.
It looks like it's broken.
Well, that's designed that way.
Oh, okay. So it's just two halves of a
Yeah.
Yep.
washer, basically.
So
we
now I got to rotate because
We got half of them, huh?
these studs weren't supported.
Oh, rotate the whole thing?
Yeah, we'll take these out. Look, that string's broke. See, that's why you want to.
Inspect.
So will these springs clean up?
Nope.
No?
We'll replace them.
How come you can't just wire brush or
Because a lot of times, I mean, some of them you may be able to, but a lot of times,
There's a.
because it's rusted to the point to where it's decayed the material, so it may only have a few cycles left in it. See, that spring's broke.
So what do you think about these pins? I think they look good.
I cleaned the other ones up there over there in that box.
We clean the shaft too.
Yep.
Will they work?
Huh?
Will they work?
Yeah, they work.
Okay.
Look at that. It's just sat in the bottom.
Yeah.
See that?
Your witness mark in
Yeah.
the water. Hopefully it's not broken.
Okay.
So let's see here. We can
Flip it over.
Yep.
Whoop. That side's good. Okay. So how did we bend this one? Did you drop this one?
It could have been one of.
No care for in the world for these
Oh,
we
sheep.
can straighten
well,
it
but
back
we
up.
knew we were going to replace it. It's interesting. Isn't it?
What was your
I don't
question?
I don't remember seeing these lines in the other one.
Well, they're different brands.
Are they in?
But
Must
that's-
have some bronze in it.
yeah.
Yeah, I see some
Or
green.
copper. Or,
Yeah.
Are these better or worse? Same. It looks like the teeth are worn less.
Yeah, these are a lot better.
So are you gonna keep these as inventory?
Yeah, these would just be spares.
Well, but remember it was bent on several of them.
Well, you can straighten them out.
Okay.
He bent them.
Now we gotta take that little screw out. That's called a Dutchman. They
Got
got
a set screw?
Well, no, it is a set screw, but when it's driven between two types of materials, we call it a Dutchman. I forget what other people call it, but that's designed so this cannot move at all. And hopefully this will move. Oh yeah, this is not near as tight as the other one. Oh yeah.
So is this looking like it's in actually better shape?
Well, I mean, it's coming apart a lot easier, and this nut's not eat up as bad as the other one was.
All right, Dad. So you got the bearing out now. How's it look?
Full of grease. The other one didn't have any grease in it. I think that's gonna be just fine.
It doesn't sound bad.
Let's clean it up. I think this one. This one may still be alright.
It sounds awful rough.
Well, it doesn't have any grease or lube in it right now. That doesn't have any side play. I think I'll replace it.
You'll replace this one?
Yeah.
That's pretty loose.
As much trouble as it takes to get to it. to have my Valentine here with us today.
Oh, yeah.
So anyway, that's what we're doing today on Valentine's Day. Celebrating by working on tractors.
Okay, so now that we have the clutch packs out, cleaned out, the final drive compartment's pretty ready to go. Dad and Dennis are going to continue working on taking the final drive pinion disc out, cleaning that area up, working on some of the threaded bolt holes. Silas and Jonathan are going to be sanding on the chassis, getting that cleaned up, ready to be washed and then painted. And then I'll be up at the front, picking up where Silas and Jonathan left off, cleaning the clutch packs.
Let's get to it.
Okay, so I just got both clutch packs done. They're just sitting together, pieced together so the parts stay with the original pack they came with. But those are looking great. You can see the two final drive discs that Dad and Dennis just got out. But how's your progress, Dad?
Made good progress. We took the pinion plate off, and that seal was bad. This seal was good, so it was a good thing we went ahead and took that off. So the bearings are good. I've got new seals, and then I wanted to put new seals in this part too because this holds oil, and there's oil on this side. So obviously that side was leaking because you can see all the black. This side wasn't. So we got that broke down, got the steering clutches disassembled, identified that we needed plates and discs, so we're going to order those.
Engine block.
The Cole and Silas got the engine block all cleaned up. And
Sitting over there wrapped up in the blue blanket.
yep, the next step for it will be wire brush the exterior. If you didn't do it already, I don't know. Kinda, sorta.
We wire brushed all the surfaces that are supposed to be, flat and shiny, like everything like a gasket would go on, but we didn't sand it. But it did get steam cleaned. So
Okay, we'll wait until it's buttoned up, and then we'll
yeah,
get paint ready. But
it's once it air dries, it's ready for clipped off.
yeah. So the casing here has been rough sanded, needle scaled. All the threaded holes have been tapped. We're gonna wash it one more time to get these cases good.
There's a few more places that need sanding.
Yeah. Well, I mean, just initial.
Yeah.
So we're probably one more work day away from getting some Gliptol in here and primer on the exterior of the housing. There are a few cracks inside that side that I've got to repair. Somebody already repaired this side, but these have a tendency to do that anyway, and we'll cover that in the next episode.
But once again, we had a phenomenal work day.
Had a great work day. Had lots of helpers.
Thank you to everybody who showed up. We literally can't do it without you.
Yeah.
So catch us in the next episode.
Appreciate you watching, and don't forget to like and subscribe. We don't say that often, but anyway, I'm going to say it this time.
And keep making tracks. See you in the next one.